Hi everyone, new topic equilibrium versus steady state. So consider a cup of tea whose temperature is 70 degrees Celsius. This is system. Okay, then this is a surroundings is an ambient air is a thermal reservoir. So what is thermal reservoir? If a thermal reservoir will absorb or reject heat, but you cannot see any change in temperature. Okay, they can absorb or reject heat, but we cannot see any change in temperature. The temperature will be constant. So surroundings is a thermal reservoir, so the temperature is 27 degrees Celsius. So system temperature is 70, surrounding temperature is 27. We know heat is always flowing from high temperature region to a lower temperature region. So here heat will flow from system to surroundings. At last, T system is equal to T surroundings. So the cup of tea temperature is, the tea temperature is reduced to 27 degrees Celsius. So system temperature is 27, surrounding temperature also 27. So this condition is called thermal equilibrium. So generally we can tell equilibrium. So at that time delta T system minus T surrounding is equal to 0. Then once it reach thermal equilibrium, check the temperature. Then after 10 minutes you check the temperature of system and surrounding. System temperature is 27, surrounding temperature also 27. After 30 minutes you check system temperature is 27, surrounding temperature also 27. So temperature is constant over time. So mathematically you can write dt by dt is equal to 0. T is the temperature, small t is a time. Then dt is equal to 0. T system minus T surrounding is equal to 0. dt by dt is equal to 0 and this dt is equal to 0. Then let us discuss what is steady state. A cup of tea whose temperature is 70 degrees Celsius. This is the system. Then surrounding temperature is 27 degrees Celsius. So this tea temperature, I am going to give a continuous supply of heat by using a heater, and this will keep constant 70 degrees Celsius. Heat is flowing, but by using a heater I am going to keep the temperature as 70 degrees Celsius. So after 10 minutes, you check after 10 minutes, system temperature is 27, surrounding temperature is, system temperature is 70, surrounding temperature is 27. System temperature is 70, surrounding temperature is 27. After 20 minutes, system temperature is 70, surrounding temperature is 27. After 30 minutes, system temperature is 70, surrounding temperature is 27. So the temperature is constant over time. So here one thing is that delta T is equal to 70 minus 27, that is 43. So what is the difference between this equilibrium and steady state? In equilibrium you can see T system is equal to T surroundings, but in steady state T system not equal to T surroundings. And one more thing, during equilibrium there is no heat flow from system to surrounding. Once it reach thermal equilibrium, this temperature is 27, this one also 27, but here no heat flow. But here 70 degrees Celsius is the system temperature and surrounding temperature is 27 degrees Celsius. So a constant heat flow is maintained. Then mathematically we can write dt by dt is equal to 0 because temperature is constant over time. But dt is 43, dt not equal to 0. So more generally we can explain, if x is a state property, in the case of equilibrium dx by dt is equal to 0 where dx equal to 0. But here dx by dt, in the case of steady state dx by dt is equal to 0 where dx not equal to 0. Okay. Then third point, death and sleeping. See, death and sleeping, we know we were in dormancy. We can't identify what's happening outside and all. We don't know what's happening outside. Then how can you differentiate death and sleeping? Simply you can tell death is a state of equilibrium, and this is the condition of sleeping is steady state. Death is equilibrium, but sleeping is steady state. How? Just to check this. Death, at the time our body temperature will reduce and surrounding temperature is 27, so this one is in thermal equilibrium. That time body temperature is reduced, so dt is equal to 0 and dt by dt is equal to 0. But while sleeping, during sleeping, so in our body many biochemical operations were going on, and our body is just like a chemical industry. Many processes were going on, releasing energy, continuous supply of energy, keeping our body temperature is 37 degrees Celsius, surrounding temperature is 27. So dt is equal to 10, but dt by dt is equal to 0. No change in temperature over time, but the change in temperature you can see. So this is the exact difference between steady state and equilibrium. Then let us discuss about the definition. The condition of equilibrium. Here the state properties remain constant over time, but no work or energy required to maintain this condition. Very important. Here, keeping this condition, T system is equal to T surrounding. After that, I don't want to give any extra energy and all. I don't want to give a work. I don't want to give any extra energy for keeping this condition. But here, what is steady state? So it is the condition where the state properties remain constant over time, but a continuous supply of work or energy required to maintain this condition. Here I am going to give a continuous supply of heat, thermal energy, by using a heater continuously supplying thermal energy. So this is the definition of equilibrium. This is the definition of steady state. Okay, thank you.